Let's start revision of wave. Let me define new questions related to this chapter. First, you will be asked to define property of medium, propagation of mechanical wave. I define you for propagation of mechanical wave. Medium must offer three different properties. First, it must be elastic. Second, it must be inertial. And third, it must offer minimum opposition or minimum friction so that there will be least loss of energy or very less amount of loss of energy. Next question will be, on the basis of propagation of transverse wave and longitudinal wave, you will be asked to define transverse and longitudinal wave, on the basis of vibration of particle. So in transverse wave, particle oscillate or vibrate perpendicular to the propagation of wave. In longitudinal wave, oscillation of a particle will be along propagation of wave. Next question related to this part will be, you will be asked why transverse wave can travel through solids only, but longitudinal wave can travel in all medium. Hamza, any idea for this part? Why transverse wave can travel through solids only, but longitudinal wave can travel through all medium? Just 1 minute. In this part, longitudinal wave, according to the formula, velocity of longitudinal wave or transverse wave is simply tension divided by mu. If you transform this particular relation using the concept of Young's modulus, according to the formula, Young's modulus equals to stress divided by strain. Stress is equals to force divided by area of cross section. multiplied by strain. So force is also equals to tension. So we may write tension equals to force is equals to Young's modulus into an area multiplied by strain. Next, rho, which is equals to mass per unit volume, which is also equals to area into length. And mass per unit length is called linear mass density mu divided by A. So you may write mu is equals to rho into A. Now we have both tension as well as mu. So if you substitute in this part, you will get velocity is equals to root under tension, which is equals to Young's modulus into area into a strain, divided by rho into A. A and A will cancel out. So you're left with Young's modulus divided by density multiplied by strain root under. So in this expression, we have velocity depending on Young's modulus. And we know Young's modulus depends upon or defined only for solids. That's why transverse wave can travel through solids only. Hamza, is it clear?
Yes, sir. Like I thought that it might be like the intermolecular forces would in solids would be more, so that's why it can travel like that.
Okay. You may also define this particular transverse wave as it depends upon elasticity in shape of that particular object. And we may define elasticity in shape only for solids. That's why transverse wave can travel through solids only. In case of longitudinal wave, velocity of longitudinal wave was beta divided by rho, and beta is bulk modulus, which may define for all different medium. But in case of solid, liquid, and gas, bulk modulus is maximum for solid, than for liquid, and than for gas. Hence, maximum velocity of sound or longitudinal wave is through solids, then liquid, and then gas. Just like in solid, let's say aluminum, speed of sound is about 6,000 meter per second. In case of water, velocity of sound is about 1,500 meter per second. Gas, just like air, it is about 3 meter, 0 meter per second. So we may define velocity of sound on the basis of bulk modulus of different medium like this. Khalid, any doubt?
No, sir.
Okay. Next question will be, find ratio of RMS velocity of gas and velocity of sound. I defined with this part. RMS velocity of gas is 3p divided by rho root under. In case of velocity of sound, it will be gamma times p by rho. Now divide these two expressions, you'll get required ratio. Next question, you'll be asked to define Newton's assumption of velocity of sound and then Laplace correction to it. So for propagation of longitudinal wave, that is sound, Newton's assumption was it should be isothermal in nature. So beta for isothermal process will be equals to pressure. And if you substitute pressure and density for air, it will be 280, which is smaller as compared to normal speed of sound in air. According to Laplace, propagation of sound will be adiabatic in nature. In case of adiabatic process, beta will be equals to gamma times p. So on substituting their value, you get the required term. So this is all about the first part of wave, that is longitudinal and transverse part. Next question will be on the basis of equation of traveling wave. Equation of traveling or stationary or standing wave. Suppose you have y is equals to a times sine omega t minus of kx, and you have y is equals to 2 times of a sine kx cos omega t. So if omega t and kx within the same bracket, then it will be traveling wave, and if they are with different function, so it will be stationary or standing wave. Now related to this expression, you will be asked to find wavelength, time period, frequency. So you may write omega, which is coefficient of t, which is equals to 2 pi by capital T, or simply 2 pi into frequency. Next, k, which is angular wave number, which is also equals to 2 pi by lambda. So from this part, you will get wavelength of the wave. Next, you will be asked to define wave velocity or phase velocity, which is equals to lambda by t, lambda times frequency, or simply omega by k. This is equation of stationary wave. So from this part also you'll be asked these different part or the different term. Hiba, any doubt? Next question will be, suppose if you differentiate this particular displacement, you will get particle velocity, which is equals to omega a cos omega t minus of kx. So in terms of displacement, maximum displacement is amplitude, which is a, but in terms of particle velocity, amplitude of particle velocity will be also called maximum particle velocity. So this particular part is also called amplitude of velocity, which is also called maximum particle velocity. So you're asked to calculate amplitude of velocity or maximum particle velocity. Similarly, if we differentiate it again to find particle acceleration, so it will be minus of omega square a sine omega t minus of kx. So in this part, coefficient of sine is amplitude of this acceleration particle acceleration. So this is called amplitude of particle acceleration, which is also called maximum particle acceleration. Next question from this part, we will be asked to define particle velocity and phase velocity or wave velocity, or what would be the difference between these two parts or these two different velocity. You will be asked to simply define these two parts only. Hamza, any doubt?
No.
Okay. Next is beats. For this part, you will be asked to define beats Next, you will be asked to derive its expression. Or simply show that beats frequency is difference of frequency of two wave. Or simply show that beats frequency is equal to difference of frequency of two wave. So I defined you the last derivation of this particular chapter like this. Y1 is equals to A times of sine omega 1 times t, and similarly y2 is equals to A times of sine omega 2 into t. And just adding these two terms, you will get required answer like this: 2 times of A sine pi f1 plus f2 cos pi f1 minus f2. So in this part, this function will define you the oscillation of amplitude, and this function will define you the number of beats. So beats frequency will be the difference of frequency of these two waves, like this. Graphically, you may define as on superimposition of two waves, a wave like this. Like this. So in this part, the outermost will be difference of frequency of two wave, and the inner one will be sum of frequency of these two waves. So the outermost will simply define you beats, that is loud sound and faint sound, and combination of that part. That is from this point to this point is one beat. This point to this point is one beat. So in total, this particular structure have 4 beats. Hamza, is it clear?
Yes, sir.
Now the next question will be, up to what frequency of beats we can hear it? So there is a term which is persistence of hearing. And for normal adult, it will be 1/10th of a second. It means if two different sounds are differ in time by this much amount, it will be recognized by our brain as two distinct sound. But if it is, or if there is gap of time between any two sound less than this particular part, it will be recognized by our brain as just single one. So if you have to define beats as two distinct sound, one is loud sound and faint sound. So the frequency of beat must be less than 10 hertz so that the time period or the time gap in between loud sound and faint sound will be more than this particular part. So we can say for beyond 10 hertz beat frequency, we can't recognize it as beats. Khalid, is it clear?
Yes, sir.
Okay.
Sir,
Yes.
so like if you have to distinguish between two beats, like it will depend on the frequency.
Yeah.
Okay, sir.
Beats is simply the superposition of two waves having slightly different frequency, may have same or different amplitude, but preferably amplitude should be same and phase should be same, but frequency should be different. And the difference of these two frequency must be less than 10 hertz. That's why we can hear loud and faint sound distinctly, according to the concept of persistence of hearing. So we can say beats frequency should be less than 10 hertz. So this is all about this entire wave part. So these are most famous questions related to this topic. Now just tell me any doubt in this entire chapter wave.
No, sir.
Hamza?
No, sir.
Okay. You have written this entire one, different one? Okay. Next is oscillation. In this part, we have three different sections. First one is displacement, velocity, and acceleration. Second is energy. And third is calculation of time period. So let me define the first part. How you recognize any particular function to be in SHM or periodic or not periodic. First, if function is trigonometric, that will be periodic. In trigonometric function, we have 6 different types: sine, cos, tan, cosec, sec, and cot. In this 6 different function or trigonometric function, only sine and cos ranges from -1 to +1. So for this particular equation, we may have fixed amplitude of oscillating body. Rest of the all other functions, their range of values will be from -infinity to +infinity. And for oscillating body, we can't define amplitude to be infinity, so it will be not possible. So for SHM or oscillating constant amplitude, only function will be sine or cos. Next is, suppose you have y is equals to some constant a sine to the power n omega t. N may be of 1, 2, 3, anything. If n is equals to 1, then it will be SHM. Otherwise, if n is not equals to 1, it will never be SHM. Both should be periodic. SHM is special type of periodic in which body oscillates or vibrate about their mean position, or it get directed towards mean position always. Suppose this is any support. This is mean position. If you displace a bob towards this direction, and motion is like to and fro, to and fro. So at each instant, this particle will get attracted towards mean position. So acceleration of body will be directed towards mean. Then this motion or periodic motion will be called as SHM. Hamza, is it clear?
Yes, sir.
Next, suppose you have superposition of two SHM, just like sine omega t, cos omega t. And let me define you another example, sine omega t and sine 2 omega t. So in first example, we have omega and omega, but in second one, we have omega and 2 omega. So you will say this is simply addition of two SHM. In physics, we call addition as superposition. So superposition of two SHMs, this one and this one, will be also SHM only if their angular velocity is same. So in this part, we have same angular velocity, but in this part, we have different angular velocity. So it should be never be SHM, but this will be SHM. So superposition of any two SHMs will be SHM only if their angular velocity is same or time period is same. So these are some property related to SHM or periodic or non-periodic functions. In doubt? Suppose you have y is equals to a times of sine square omega t. Is it SHM or periodic, non-periodic? Hamza, just tell me. Since this particular function is trigonometric, that is sine, so it will be periodic function. Next, just take the exponential of this particular function, that is 2. So for SHM, it should be just 1. And since we have in this part 2, so it will never be SHM. It will be periodic, but not SHM. Is it clear, Hamza?
Yes, sir. I was just having a little doubt because of the exponent.
Okay. It may be written as a times of sine omega t and whole square, like this. Both are same. Suppose you have y is equals to a times of sine omega t and cos omega t. Whether this particular function is a SHM or not. It will be like a times of sine square omega t, but this will be a times of sine 2 omega t divided by 2. So it will act as a stem, but it will be not a stem. So we can say product of 2 SHM will be SHM if it results into some linear term or with same angular velocity like this. Otherwise, in this part, it will never be SHM. Hamza, any doubt?
No, sir.
Okay. Now we have 3 different terms, that is displacement a times of sine omega t. Next is velocity omega a cos omega t. And next is acceleration minus of omega square A sine omega t. So one of the questions will be to find phase difference between these three different parts. So y, v, a, phase difference between this part will be pi by 2. This part will be pi by 2. And between this one and this one is pi. Next question on related to this part will be to derive general differential equation of SHM. To derive, acceleration is directly proportional to general differential equation of SHM. You may be asked to define, show that in SHM, acceleration is directed towards mean position, or you may be asked to define acceleration is proportional to displacement with negative sign. These two questions are same. You may write this acceleration as second differentiation or double differentiation of displacement with respect to time is equals to minus of omega square, and this a times sine omega t is also called x. If you move this particular expression to left side, you will get required differential equation or general differential equation of SHM. Next, there will be question on the basis of these equations to find displacement, angular velocity, frequency, amplitude related to this part, which is similar to what we did in V. Khalid, any doubt?
No, sir.
Okay. Next part is energy. In energy, we have three different expressions. First is potential energy, half m omega square y square. Second is kinetic energy, half m omega square a square minus y square. And third is total energy, which is half m omega square a square. So from this part, you will be asked different relation. Suppose find displacement for which kinetic energy equals to potential energy. Find displacement for which kinetic energy is 75% of total energy. So you may equate on the basis of the given condition. Like in this part, we have kinetic energy is 75% of total energy. So you may write expression of kinetic energy as half m omega square a square minus y square. 75% means 75 by 100. An expression of total energy half m omega square a square. So in this part, half m omega square will get cancelled out. So you're left with a square minus y square is equals to 3 by 4 times a square. Or you may write y square is equals to 1 by 4 times of a square, or simply y is equals to plus minus a by 2. So on the basis of their relation like this, you may find displacement for different conditions. Hamza, is it clear?
Yes, sir.
Next, also in this part, you will be asked to draw the variation of potential energy, kinetic energy, or total energy with respect to displacement. So you may draw graph like this. This is potential energy, which is minimum at mean position. This is kinetic energy, which is maximum at mean position. And this is total energy, which is constant throughout. So these different questions will be asked from this part. You may be asked to derive these all or these different relationship or graph related to this part. Next, on the basis of calculation of time period, we have two different parts. First one, spring mass system. There might be question based on spring constant. Suppose this is any spring, and if it is cut into let's say 4 equal parts, how will be spring constant be affected? Or what would be new spring constant for this part? So according to the formula, Young's spring constant is equals to YA divided by L. So if it is divided into 4 equal parts, one of the segment will be L by 4. So if you calculate K for this segment, it will be YA divided by its length, that is L by 4. This is nothing but K, so it will become 4 times K. It means on cutting down spring into n number of segments, its spring constant becomes n times K. So you may write if spring is cut into n equal parts, K dash becomes n times K. Hamza, is it clear?
Yes, sir.
Next question on the basis of this part will be arrangement of combination of spring, that is series combination, parallel combination. Like in series, we had this one, this one. It may be horizontally or vertically. Formula will be same. This is series combination. So K equivalent for this part will be simply 1 by K1 plus 1 by K2. In terms of parallel combination, one of the argument will be this or this. So if you displace this particular block towards any one direction, displacement will be same in both one So both is parallel combination. So in parallel, K equivalent will be simply sum of individual spring constant, that is K1 plus K2. Now on knowing K equivalent, time period will be equals to 2 pi root under mass of block divided by K equivalent. You calculate time period related to these oscillations. Khalid, any doubt?
No, sir.
Next, simple pendulum. For this part, you will be asked to derive expression of time period for oscillating bob connected in a string. From any support a bob is connected let's say this particular angle is theta, so it will be experiencing mg. If you extend this particular line and break its component, it will be mg cos theta, mg sin theta. So in this part, mg sin theta component will be responsible to bring this bob back to its initial point. So it will be treated as a restoring force in this part. So F restoring is minus of mg sin theta. And since this particular angle is small, so you may write sin theta as simply theta. Further, it will be theta is equals to perpendicular by base or simply length of arc by radius. Length of arc is L, X, and radius is L. So it will be X by L. Coefficient of X, just like spring, F is equals to minus of Kx. So X or coefficient of X will be K. So we may write this particular to be K. So time period is equals to 2 pi root under M by K. K is mg by L. M and N cancel out. So you're left with 2 pi root under L by G. In this expression, L simply defines you the distance of center of mass of bob from axis of rotation. And this G is net acceleration of system. This is net acceleration of system. And this is distance of center of mass of bob from axis. So there will be various other factors to define or to change this particular gravity. Let's say this is surface of Earth, and suppose if you move to mountains, so you'll be asked what will be the effect of going on mountains on oscillation of simple pendulum. So as we know, according to the concept of gravitation, as we move from the surface of Earth towards altitude, gravity decreases. And with decrease in gravity, time period of oscillation of pendulum will increase. Similarly, if we move into mines or inside of surface of Earth, also gravity will decrease, hence time period will increase. So on going on hills or mines, gravity decreases, time period increases. In this part, gravity due to depth decreases and time period increases. Next, suppose you have lift. So in case of lift, if it going upward with some acceleration a, net acceleration on oscillating body or body placed on inside of this will be g plus a. In case of descending, net acceleration will be g minus a. In case of free fall, net acceleration will be 0. In case of uniform motion, whether it is going upward or downward, for uniform motion, acceleration is 0. So net acceleration will be simply g. So we may define oscillation of simple pendulum according to these different conditions. Khalid, any doubt?
No, sir.
Hamza, just tell me what will happen in free fall to the time period of oscillating simple pendulum. If simple pendulum is placed in lift, which is under free fall, what will be the value of time period of oscillating simple pendulum? Just put the value of net acceleration in the above expression.
That it will reach to infinity.
Good. If you substitute net acceleration to be 0 in this part, any number divided by 0 will be infinite. It means time period will be infinity. It means pendulum will retain its position as it is, or it will behave as it is at rest. If it is in bend state, it will stay there while free fall. So these are different problems you will be asked from this part, simple pendulum. Let me define you one more thing. Oscillating liquid. Suppose in U-shaped tube, initially level of liquid is up to this part. Now, if it displaced or compressed liquid from any one side, let's say in this part, if it is being compressed down by this amount, let's say y. So equal volume of liquid will rise up along this direction. So level of liquid from this point will rise up to this part, y. So difference of level of liquid in between these two segments will be 2y. So according to the concept of fluid, you will say if there is difference in level of liquid, so it will generate some pressure difference. So in left arm, we have liquid slightly at higher level. So it will generate some gauge pressure as compared to the right one. So according to formula, a restoring force will be net pressure multiplied by area of limb of this capillary tube and with negative sign. Pressure in this part will be rho g h, which is y times a. Now take out the constant part and variable part. So we have 2 rho ga multiplied by y, which is similar to F is equals to minus of kx. So coefficient of x in this part is k, which is called spring constant. So coefficient of displacement in this part is 2 rho gy ga, which is a spring constant or behaving as a spring constant. So time period will be 2 pi root under m by k, and k we have 2 times rho g. Hamza, is it clear?
Yes, sir.
So we can say liquid in U-tube will also oscillate according to SHM or simple harmonic motion. It will perform. Khalid, any doubt?
No, sir.
Okay. You may write it down. Hamza, done?
Yes, sir. Done.
Now the next part is the undamped oscillation and damped oscillation. In most of the school, it is deleted portion, but from that part, you will be asked to define only definition, that is what is undamped oscillation, damped oscillation, resonance frequency. That's it. You'll be asked to define these written term. Otherwise, it will be deleted. There will be no any other question from this part, that section. So this is all about this entire oscillating or oscillation or SHM. Any doubt? Please ask from these two chapters, oscillation wave. Hamza,
Yes, sir.
any doubt?
Sir, I'm looking for one, searching
Okay.
for one.
Okay. When is your final exam?
Sir, from 14 March.
Okay, 14 March. And when is your pre-board?
Going on, sir.
Okay. So when was physics paper?
Sir, on Wednesday. Like,
Okay.
we'll have on Wednesday.
On coming. That is day after tomorrow.
Yes, sir.
Okay. How much you have prepared?
A little more than half. Like the
Okay.
first, the starting chapters.
Okay. Maximum weightage will be from fluid, oscillation, and waves. And rest of chapter will be very small part or having very less weightage. So any doubt?
I have received a question paper from the mom school,
Okay,
and in that there is like no question from oscillation and just one question from wave that took case study.
just 1 minute. I'm sending you question paper. Did you receive anything in chat box?
Yes, sir.
You may go through this paper. The second one is based on solid and fluid only. Khalid, just ask me any question you have.